On the 24th of March, in the year 536, the sun over Constantinople began to fail. It did not go out. It went dim. The Byzantine historian Procopius, writing a few years later in his History of Justinian's Wars, said the sun gave forth its light without brightness, like the moon, and that it kept doing that for the whole year. In Italy, the Roman statesman Cassiodorus wrote letters describing a noon that cast no shadows and a grape harvest ruined by frost. In southern China, court chroniclers recorded a yellow, ash-like substance drifting from the sky. In Ireland, the annals recorded a failure of bread. 4 literate societies, thousands of miles apart, writing in 4 scripts, describing the same broken sky in the same year. For 14 centuries, nobody could say why. Then glaciologists pulled a core of ice out of northwest Greenland and counted the layers. What they found at the layer for 536 was not one volcano. It was volcanic glass carrying 3 separate chemical fingerprints. And the mountains they pointed at were not in Italy or Iceland or Indonesia. They stood in western North America, which raises a question nobody has answered. If the volcano that dimmed the Roman sun was standing in California or Alaska or British Columbia, who was standing next to it? To answer that, we have to begin with the physical evidence. And the oldest witnesses still standing are trees on a dry white ridge in eastern California. The White Mountains rise east of the Owens Valley, across the desert from the Sierra Nevada, and near their tree line grow bristlecone pines. Pinus longeva, twisted, half-dead, orange-barked things clinging to dolomite at 11,000 feet, and some of them have been alive for more than 4,000 years. Their growth rings are the reason we can date the year 536 at all. When a hard frost hits a conifer while its new wood is still forming, the cells freeze mid-construction, they collapse, deform, and then the tree carries on growing around the damage. The result is a frost ring, a permanent scar of crushed cells sealed inside the trunk at one exact calendar year. In 1984, Valmore Lamarche and Catherine Hirschbuck published a paper in Nature titled Frost Rings in Trees as Records of Major Volcanic Eruptions, using bristlecone pine from the western United States. Matthew Salzer and Malcolm Hughes expanded that dataset in 2007 with upper treeline sites across the Great Basin. Here's the part worth sitting with. Across the 3 great long tree ring chronologies of the Northern Hemisphere, bristlecone pine in western North America, Scots pine from northern Finnish Lapland, and Siberian larch from the Yamal Peninsula in Arctic Russia, there are only 2 calendar years where frost rings appear in all 3 at once. One is 1627 before the Common Era, the other is 536. There is more. Siberian pine at the Mongolian timberline shows frost damage in the same year, published by Rosanna de Rigo and colleagues in 2001. And in 2022, a team led by Ulf Bündgen went further, cutting 106 wood anatomical thin sections from 23 forest sites and 20 tree species in both hemispheres and staining them to look for cell-level damage. They found 89 blue rings where the cell walls never finished hardening, 9 frost rings, and 93 light rings. The strongest single cold signal in the entire network fell between the middle of July and the beginning of August in 536, across North America and across Eurasia at the same time. Think about what that means physically. Somewhere at high elevation in the American West, right now, there's a bristlecone pine still alive, still putting on wood, that carries a band of crushed cells laid down in the summer. The Byzantine sun went pale. You could put a fingertip on the year, but a tree can only tell you when it got cold. It cannot tell you why. For that, you need ice. If you enjoy documentaries built out of original records, archaeology, and indigenous accounts, consider subscribing. Because the ice core drilled in northwest Greenland turned out to hold something considerably stranger than a temperature record. The core came out of a drilling site in northwest Greenland called Neem, and in 2015, a team led by Michael Seigel published its analysis in Nature. Their key move was a calibration trick. Cosmic ray events in the years 774 and 993 left identical chemical spikes in both tree rings and polar ice, which let the team pin the ice chronology to the absolutely dated tree ring calendar. That correction shifted the ice layers by several years, and suddenly the volcanic record and the written record lined up. 2 enormous sulfate signals appeared, one at 536 and a second at 540. Then they went looking for ash. Sulfate tells you an eruption happened. Only glass tells you where. From a sample of ice weighing 251 grams, cut from the depth matching 536, the team filtered out at least 17 shards of volcanic glass. That is the whole harvest, 17 specks, each between 20 and 80 micrometers across, invisible without a microscope. And here is the thing that makes the sample so peculiar. The shards did not match each other. They differed in shape. They differed in chemistry. Some were andesitic, some trachytic, some rhyolitic, which is another way of saying they came out of different magmas inside different mountains. When the compositions were compared against known volcanic systems, 3 regions came back. The Aleutian Arc in Alaska, the Northern Cordilleran Volcanic Province in northern British Columbia, and the Mono craters, a chain of rhyolite domes on the eastern flank of the Sierra Nevada in California. Seigel's team wrote that this indicated at least 3 synchronous eruptive events, all of them situated in western North America between 38 and 58 degrees north. 3 mountains, roughly 2,000 miles apart, going off at once, and none of them anywhere near a person who could write, which is the strange asymmetry at the center of this story. The eruptions happened along the western edge of one continent. The paperwork happened on the far side of the world. Michael the Syrian, compiling his chronicle from earlier Syriac sources, recorded that the sun shone feebly for a year and a half. The Annales Cambriae, the Welsh annals, note a mortality in Britain and Ireland in 537 and never say why. The Mandaean Book of Kings, written in southern Mesopotamia in the early 7th century, describes grain in those years so scarce that gold could not buy it. In northern Italy, a severe famine struck in 538, and the explanation offered at the time was that the fields had gone uncultivated the season before. Northern China recorded a famine bad enough that one surviving document reports cannibalism, and while the mortality figures in that source are extreme enough that historians handle them with tongs, the famine itself is not in question. If that reading holds, then the year the Byzantine sun failed did not begin in the Mediterranean at all. It began in the homelands of the Unangaks of the Aleutian Islands, of the nisga'a and their neighbors in the northern British Columbia interior, and of the Quetzalcoatl Paiute of the Mono Basin. That is a large claim, and it deserves a hard look before we go one step further. Start with the sample size. 17 glass shards is very little to hang 3 volcanoes on. Glass and ice can be reworked, lifted off old ash deposits by wind, and redeposited centuries after the eruption that made it. Heterogeneous chemistry can mean 3 simultaneous eruptions. It can also mean ordinary atmospheric dust, doing what dust does. Then there is the vent problem. No crater anywhere in western North America has ever been dated to 536. The Mono chain has produced eruptions every 250 to 700 years across the last 3,000 years. So an unrecorded event in the 6th century is entirely plausible, but plausible is not the same as found. Nobody can walk you to the hole in the ground. There's also a mismatch inside the science itself. The tree rings say 536 was extraordinary, arguably the coldest single summer of the last 2,000 years. But when Seigel's team ranked eruptions by the global radiative forcing preserved in the ice, 536 came out only 18th strongest of the last 2,500 years, and 540 came out 5th. Those 2 findings do not sit comfortably beside each other, and researchers have spent the years since arguing about whether climate models underestimate high-latitude eruptions, or the tree rings overstate the cold, or the sulfate estimates are simply too low. Add a drought that had already been gripping Persia and the Levant since roughly the year 522, and one clean catastrophe starts looking like several overlapping ones. And there is a rival suspect. In 2018, a team including Michael McCormick of Harvard and Paul Majewski of the Climate Change Institute in Maine analyzed an ice core from the Colle Nifedi Glacier in the Swiss Alps at extraordinary resolution. In ice from the spring of 536, they recovered 2 particles of volcanic glass whose chemistry resembled Icelandic volcanic rock. Seigel said openly that he wanted better evidence before accepting Iceland over North America, and critics have pointed out that the Alpine core's dating at that depth is less precise than the Greenland record. The Americas side of this story has also already lost one of its biggest pieces. For decades, the favorite candidate was Ilopango in El Salvador, whose Tierra Blanca Joven eruption buried Maya settlements under meters of white ash. Then, in 2020, a team led by Victoria Smith published in the Proceedings of the National Academy of Sciences, having found the Tierra Blanca Joven ash inside precision-dated Greenland ice. Their date was 431, give or take 2 years, a full century too early. The Maya connection went with it. The famous gap in monument dedication at Tikal, the hiatus, is now mostly attributed by Mayanists to a military defeat in 562 at the hands of Karakol and Kalatmul, and that gap was largely confined to Tikal, while rival cities carried on building. And one more honest gap, the one that matters most for this channel. No indigenous oral tradition in North America has been securely tied to the year 536. Not one. That absence is real, and it should be said plainly, which makes the Norse material worth a close look, because Scandinavia is where somebody did make the argument and made it in a peer-reviewed journal. In 2012, Bo Gresland and Neil Price published an article in Antiquity called Twilight of the Gods, the Dust Veil Event of AD 536 in Critical Perspective. Their subject was Fimbulwinter, the great winter of Norse tradition that precedes Ragnarok, the end of the world. The Old Norse sources describe a sun turned black, a land sinking into the sea, and a run of winters with no summer standing between them. Gresland and Price argued that this was not invented cosmology. It was a poetic memory of a real climatic catastrophe. Their supporting evidence was archaeological, not literary. Across 6th century Scandinavia, the settlement record shows farms and whole farmlands going out of use on a large scale. And there is the gold. In 1999, the Danish archaeologist Morten Axboe published a paper in Medieval Archaeology titled The Year 536 and the Scandinavian Gold Hoards, noting that the deposition of gold in Scandinavia spikes and then ends around the close of the migration period. Gold ornaments and stamped gold pendants buried in quantity by people who did not come back for them. The scale of that abandonment is what makes the archaeology hard to wave off. Working in the Mälaren Valley of eastern Sweden, Daniel Lowenborg argued in 2012 that the 536 event acted as a shock that reorganized land ownership and social structure across the whole region. In eastern Norway, large elite estates appear to have been broken up into smaller production units, which reads much more like a survival strategy than a fashion. Farms in the forested interior went quiet, and the woods closed back over the fields. Line it up. A sun that goes dark, winters with no summer between, farms emptying, precious metal going into the ground. Then hedge it, because Greenland and Price did. The Norse material was written down 6 or 7 centuries after 536, much of it by Snorri Sturluson in Iceland around 1220. Norwegian archaeologists, including Frode Iversen, have engaged with the Fimbul winter hypothesis, and others have pushed back hard on it, and plague, warfare, and slow agricultural change all sit in the same century competing for the same evidence. None of those parallels proves the poem remembers the year, but it does raise the obvious question. If a Norse poem could carry a volcanic winter across 700 years, could an account from Western North America carry one too? We know the mechanism works, because in one of the 3 regions the ice core points at, it has already been documented. The Nisga'a Nation of the Nass Valley in British Columbia holds Adawak, formal oral histories, describing an eruption at a cinder cone the Nisga'a call Wilksi Bakshal Mihal, meaning where the fire ran out. Geologists call it Tsiaks. The Adawak describe darkness from falling ash, a river blocked, villages destroyed, an enormous loss of life. When Lemoyne and colleagues published their eruption chronology for Tsiaks in 2022, they built it by integrating field observations and rock data with nisga'a oral and written history, and the nisga'a accounts corroborated the short duration and exceptional intensity that the deposits recorded. Tsiaks sits inside the northern Cordilleran volcanic province, the same province one of those 17 glass shards points toward. The eruption itself is only about 300 years old rather than 1400, and none of this connects the Nisga'a record to 536. What it establishes is narrower and still worth something. In that landscape, oral history and volcanology have already been checked against each other, and the oral history held up. So what is actually settled? This much nobody disputes. The sky dimmed starting in late March of 536 and stayed dimmed for many months. 4 independent literate traditions across Europe, the Mediterranean, and East Asia wrote it down without knowing about each other. Trees on 3 continents recorded the same calendar year in their wood. The Greenland ice carries a sulfate signal at 536 and a second at 540. European summer temperatures dropped somewhere between 1.5 and 2.5 degrees below the previous 30-year average, and 536 stands in most reconstructions as the coldest single summer of the last 2,000 years in the Northern Hemisphere. Bunken's team named the cold stretch that followed the late antique Little Ice Age, running from 536 until roughly 660. Here is where the questions begin. Which mountains erupted, whether it was 1 or 2 or 3 at once, whether the source was Western North America or Iceland or somewhere still unlooked at, and whether any community living within sight of those vents watched it happen and carried the memory forward in a form we have not learned to recognize. Drive Highway 395. North out of Mammoth Lakes today, and the monocraters run along the east side of the road, roughly 30 coalesced domes of gray pumice and black obsidian. Panem Crater, at the north end, has a footpath around its rim, and standing on that rim, the geology is not subtle. Obsidian underfoot, pumice ridges running south toward Mammoth Mountain, the whole chain young enough that the domes still look freshly poured. Beyond it, Mono Lake sits blue and alkaline, tufa towers standing out of the shallows like limestone chimneys. The Kutsadika Paiute, whose name comes from the alkali fly pupae their ancestors harvested along that shoreline, are still in the Mono Basin. 2,000 miles northwest, the Unangak's homeland runs out into the Bering Sea as a chain of volcanoes, most of them unmonitored and unclimbed. And in the Nass Valley, you can walk out onto black basalt at Nisga'a Memorial Lava Bed Provincial Park, established in 1992, where the tree casts left in the lava are still open holes in the rock. The sky dimmed, the crops failed. The record was kept, in ink in 4 languages and in wood on 3 continents. History is rarely solved by a single discovery. It gets assembled, one ice core at a time, one radiocarbon date at a time, one oral history that somebody finally sat down and listened to properly. That is worth remembering whenever a story like this one appears to be closing. The year 536 was a mystery for 1,400 years. Then a Greenland ice core narrowed it to a hemisphere, then to a coastline, then to 3 candidate regions, and it is entirely possible that the next real advance comes not from a laboratory, but from an archive of accounts that has been sitting in plain view the whole time, waiting for someone to ask the right question of it. Thank you for watching. If you want more history built from original records, physical evidence, and indigenous accounts treated as evidence rather than decoration, subscribe and stay with the channel. And leave a thought below. If a volcanic winter in the Nass Valley could survive 300 years in nisga'a oral history, precise enough that volcanologists now use it, what would a 6th century eruption in California or the Aleutians have to look like for us to find its record? And where would you go looking first?